Right, as you can see, I've had to simplify things just a little bit. I've got rid of the resistors, cleaned up a lot of the wires, mainly because to try and get 1 watt across there means I would have had to have shed loads of resistors. So rather than spending a fortune on high wattage resistors, all I've done is I'm changing it round so that the 5 volts are going across the collector emitter, and I'm going to put 240 milliamps across it, which will equal 1.2 watts. It's the easier way of doing it, and the lot more cheaper and more efficient way. There's my limit set on it, 5 volts and just over 500 milliamps. So same thing, as you can see, I've also got it mounted onto a heatsink now, just because I thought I might as well, to be honest, start doing that. That's how it's going to be used in real life. So let's just start it up. As you can see, it's 275 milliamps in total, but with the drop across that, means it's about 240 milliamps. Well, I know it is because I put a multimeter across it. So, there's 1.2 watts going across there. There's my little temperature sensor wire, which is going to my little temperature probe. There's the starting temperature. Okay, so rather than sit around watching it, because you know all this before, I'm just going to come back in a few minutes and see what the temperature is. Right, just a few extra things to note. First of all, this is actually a brand new 2N3055 transistor I'm using. With previous videos, I was actually using an old one. The one thing I have noticed is, for example, well, I haven't explained how I've limited the current. Quite simply, you put current into the base and that limits the currents that goes between the collector and emitter. Now I have a 3.9k resistor in there, meaning that going into the base is 1.1 milliamps. Now going across the collector emitter is 240 milliamps, and that is quite a high rise for this transistor. I'm assuming because it's a brand new one, new design most likely, which means it's got a higher, what they call HFE, or also known as gain. So, yep, well, that's basically, it's a brand new one, which is obviously a little bit better. The other thing to note is also, it's been about 6 minutes now, and it's up to 31 degrees. So, just one last thing, that's rose to 280 milliamps, which means there's probably about 245, I think, milliamps going through the collector emitter now. Okay, so I'll be back in 5 minutes just to do a very quick recap on the temperature. Be back in a minute. Right, it's been 5 more minutes and the temperature hasn't really rose, so what I'm going to do now is change the resistor going into the base of the transistor to increase the wattage to 2 watts and then see what happens. Back in a minute. Right, so just for a quick update, I've changed the resistor going to the base to a 2.2k resistor, which means there's 1.9 milliamps going into the base. Now I measured the milliamps going through the collector emitter with my multimeter, and that was 395 milliamps. So with the 5 volts means that it is 1.975 watts, basically 2 watts going across it. Now I have actually had it on for about 5 minutes already. I didn't see the point in recording the beginning of it. Obviously the temperature started, it was about 27 when it started because I just done a quick changeover. But as you can see here, there's the volts, 5 volts and 0.444 milliamps. Well, say yeah, it's 443 milliamps, minus about the 35 for powering the temperature display means there's about 410 nearly milliamps going through it at the moment, because obviously, as I mentioned before, the higher the temperature rises, the more milliamps it draws through. That's, you know, it's part of the thermal runaway thing. Temperature rises, current goes up, which makes the temperature rise higher, and it's a never-ending thing. But that temperature has been fairly steady so far, which I'm contributing to the heatsink really, and the fact that I think because it's a newer transistor, it's better dissipating the power. So it's all good. I mean, I'll leave it on 5 more minutes. If the temperature doesn't make a dramatic change, I'll just change the resistor again, put more watts through it. If it you know, if it gets anywhere near 40 degrees, I'll obviously record it again. Otherwise, I'll see you on the about 3 watts then. Thank you. Right, so next instalment is I've put a 1K resistor going to the base, which is about 4.5 to 5 milliamps going to the base. I actually measured that as starting 670 milliamps going across the collector emitter, which worked out to be about 3.35 watts. But as you can see, the amount of milliamps it's pulling has gone up because the temperature has gone up. So if you minus 40 for the temperature display and the 5 milliamps going to the base, means you got about 720 milliamps going across the collector emitter. And the temperature is, well, it's up to 45 degrees Celsius now. I have had it on for about 5-10 minutes, so it's not too bad. And the watts going through the collector emitter at the moment, I've just worked out, is 3.6 watts. So it's not too bad. I mean, the temperature has been pretty stable for the last couple of minutes. It's gone up 1 degree. So I'd say it's pretty much settled now. So yeah, so the heatsink's doing its trick. It's keeping the temperature down. So I suppose the next thing, let's try 5 watts. Back in 5. Right, this is actually going to be the final one I do for tonight. Basically, I've got a 470 ohm resistor going to the base, which means there's about 9.2 milliamps going to the base, which equals, I put my multimeter across and there's a 1.09 amps going across the collector emitter. Now 5 volts as well, so that worked out to be about 5.45 watts. So yeah, I got me 5.5 watts. Turned it on about 30 seconds ago. Started off at about 26 degrees, so it's rising quite nicely. Just to show you here as well, 5 volts, in total 1.17 amps. So obviously it's drawing a little bit more now, minus about 45 milliamps for the temperature gauge and going to the base. So it's, you know, just over 1.1 amps going across the collector emitter. So it's getting there, quite toasty, quite nicely. So there you go. So I'll be back in 5, record the temperature. So see you in 5. Right, so it's been on for just over 5 minutes now. Temperature's up to 58 degrees. It hasn't really been rising that much lately, so that's alright. Current's up to 1.2 amps, which means from the original 1.09 means it's gone up 110 milliamps, which is all good. As you can see, the temperature's even dropped back down 1, meaning it's pretty much settled now, which is all good. So 5.5 watts through with just a heatsink and no fan. Seems to be able to handle that. So I think for the next video I might set up a fan to go with it and try 10 watts and see how it'll go on there. See what I can get it up to. Okay, that's it. Thank you.